Hey everybody, this is the last video of the trig installment, Unit 4, end of the playlist. We're going to look at what's called a dot product. It's an operation on two vectors. It will give us some information about the vectors. First off, let's start out with how to calculate. We have two vectors, and I just put generic terms, u1, u2, v1, v2. U dot v, to calculate a dot product, you multiply the first entries together, add, and then you multiply the second entries together. So it's u1 times v1 plus u2 times v2. Example, if we're given vector u, which is 4, 5, vector v, negative 2, 3, and we calculate the dot product, that's 4 times negative 2 plus 5 times 3. Well, that's negative 8 plus 15, which is 7. You can also multiply using dot products with scalars. For example, u dot 2v. What you'll want to do is, I'm going to copy vector u. I'm going to double the entries of v from the last video. You can do that. Multiply them both by 2. That'll give us negative 4, 6. And then we carry through with the dot product formula. 4 times negative 4 plus 5 times 6. So that's negative 16 plus 30, which is 14. The magnitude, we did that in the last video. The magnitude of u will be the square root of 4 squared plus 5 squared. 16 plus 25 gives us 41. And since that's not a perfect square, we're going to leave it square root of 41. If theta is the angle between two non-zero vectors, u and v, then the cosine of that angle is equivalent or equal to the dot product over the magnitude of each vector multiplied together, which can also be written in a more streamlined form. Dot product is equal to the magnitude of each vector multiplied together times cosine of the angle in between. So if you know the angle between the two vectors, this will be your formula. If you don't know, then this will be the formula you use. I do want to point out that if you have a dot product that comes out to 0, then the two vectors that you dot product are orthogonal or perpendicular to one another. If your dot product is 0, your two vectors are orthogonal or perpendicular. Example, find the angle between vector u and vector v. I went ahead and drew this out to give you a visual. Vector u, which is 4, 3, start at the origin, go to 4, 3, directed line segment. Vector v, start at the origin, end at 3, 5, directed line segment. So we've got our two vectors. We're asked to find the angle between, so we're going to use the first formula from the previous slide, the one where we have cosine theta on one side. Our dot product is 4 times 3 plus 3 times 5. So it's first times first component plus second times second. The magnitude of u is going to be the square root of 4 squared plus 3 squared. The magnitude of v is the square root of 3 squared plus 5 squared. I tried to write it out pretty detailed for you. That totals out to 27 over 5 square root of 34, which is approximately this decimal value. Whenever you have an irrational term, you want to keep at least 4 decimal places. 5 and 6 are great for accuracy at the end, but 4 is usually good enough. Okay, so where we're at is we have cosine theta equals this decimal. Cosine inverse of that decimal gives you 22.17 degrees. And so that's the angle between those two vectors, 22.17 degrees. Given vector u as 2, negative 3, and vector v as 6, 4, find the angle between u and v. Well, vector u starts at the origin and quits at the point 2, negative 3. And I drew that vector here. It leads down into quadrant 4. Vector v starts at the origin and ends at the point 6, 4. so I drew that vector. It points into quad 1. Our dot product, 2 times 6 plus negative 3 times 4, that's 12 minus 12, which is 0. Well, that's what we just discussed. So vector u and vector v are orthogonal. They form a 90-degree angle. You don't even have to carry out the magnitudes. If you know the dot product's 0, it doesn't matter what these values are, because 0 divided by a non-zero is 0. Think back to your unit circle. Where is cosine equal to 0? 90 degrees. So that's just further proof visually and with a formula. I hope this video helps. Reach out by phone, email, or office hours. And I hope to see you around, and I hope this video helps. Thank you.